I'm in the warp zone again. All right, we're back. This is part two of congruent triangles. Hopefully you finished that last statement. And there's one thing I need you to add to your paper. It's kind of an important thing. Let's get this caught up. So when proper letter order, W corresponds to R, I corresponds to O. We're talking about triangle Rob is the triangle we're trying to compare that to. There's an acronym. We love acronyms. PLP, we love those things. What else? What other acronyms you have? PLPs. What's the other P one? Okay, go ahead. So this CPCTC is technically the definition of congruent triangles, and it stands for corresponding. P stands for parts. Of's in there. Congruent triangles. We're talking about those parts. So the corresponding parts, all these things, the ones that correspond have to be congruent. The definition of a congruent triangle is a triangle where all the corresponding parts are congruent. So this is just an acronym to remember to utilize this idea that all the corresponding parts have to be congruent. Big thing is going to come up later on in proofs. I'm just going to throw it out there. CPCTC, when you come back, hopefully sometime in April, cross our fingers, we'll be using CPCTC quite a bit in proofs towards the end of a proof. And of course, you know triangles have 6 congruent parts. Here's an example on the back of that page. Something a little bit more mathematical, a little numerical, where I want you to try to solve for each of these 1, 2, 3, 4, 5, 6 answers, 6 parts on there. Unless I got equal signs here, and then I jumped over to congruent signs at some point. Do your best to try to finish those 6 statements just based on the givens that you see on the screen up there. And to help you, there's also this fill in the blank on your paper. This will help you figure out which parts specifically match up. So you're not just estimating and using the scale of the drawing necessarily. You're actually using the fact that L has to be congruent to X. N has to be congruent to Z because letter order matters in this unit. Pause. Try to get 6 answers. Come back and check. So hopefully you found that X would be congruent to L. Those are both 30. N, got to be congruent to Z, 55. You got to use the triangle sum theorem a little bit here to find the remaining angles, which M and Y are congruent to each other. Add them up, subtract from 180. You should have gotten 95 for both of those. They look like they might be obtuse, so not terribly drawn off the scale on there, but maybe close. Now, the other ones, you can't find the side links, but you can say what LM is congruent to. So LM, if you're careful by letter order, should be the same as XY. That's a pretty easy matchup. And the same thing with ZX, congruent to NL. And I have a because on here. If this was in a proof, your reason would be because those are the corresponding parts, because of CPCTC. Those are the ones that match up based on letter order up there. Hopefully that makes sense. And again, just to mention this transformation part about it, what transformation would make this map onto or directly get onto the other one? It looks like it's another rotation. Whoops. Another rotation, maybe 180, probably 180 degrees on there to rotate this thing and turn it all the way around. All right, another moment to pause. See if you can find A, B, and C. Oh, it's going to be good. It's got the quadratic in there. I think it's got a system in there. This is a really good one to solve. There's one piece of information you also need after you get those things on there. This is an impossible problem to solve without letter order. So I've got perfect Spanish up there. I've got perfect, I don't know if that's Latin or what that prefix is. Penta, of course, means 5. You need to know the letter order to know which ones to match up. I love to put this problem up there in class and see who will jump to conclusions right now. And they'll go, well, that one matches up with this one and that one. They just jump to these conclusions. If you don't know where cinco goes over here, the problem's impossible. You've got to know which ones match up with which parts on there. So without some additional lettering over here, you're stuck. You might be able to figure out that N is going to correspond to N prime. But other than that, you're kind of stuck with how these match up. Another sort of thing I want to mention here with my animation, letter order matters. If C is there, I has to either be here or here. When you label a shape, it can't be random. It can't be P, E, N, T, A. It can't go like zigzag everywhere. It's got to go in a consecutive order. So I'm either going to go clockwise or I could go counterclockwise, but it's got to be in a consistent order all the way around. So there they are. See if you can find a couple equations to solve A, B, and C. So there's one thing. You see that C and I match up. You can set up an equation, set those to equal to each other. Problem with that is you get two variables and only one equation. So you'll need a second equation. If you notice down here, B minus C is on here. You know that n prime is equal to n based on the letter order above. So that allows you a second equation to solve. Now, if you clean this one up, maybe clear the fractions, you could get that relationship as well. With B isolated, I would recommend a little substitution here. Get B out of there and plug in negative 4C. It allows you to solve that second equation. So these two equations are a system of equations. You're going to love it. And you can solve those. And in this case, it does look like C can definitely be negative. We'll plug it back in and verify. If C was negative, it makes B positive, which eventually makes this angle a positive angle. If C is negative here, it makes this angle positive as well. And actually drawn, relatively close to scale on here. This would be 160 minus 20. 140, that's obtuse angle. I can live with that. I believe that. The other one ends up being a quadratic relationship. So 105 equals a squared minus 8a. You'll notice we're throwing a ton of quadratics in here. So you keep those skills solid. Factors of 105 that add up to negative 8 or subtract to give you negative 8 should have been 15 and 7. Positive 15 and negative 7 would be the two factors on there. If you plug those back in, I think they both work. Because you're squaring a negative and adding a negative here. They actually both work. They're both valid. We'll keep both of them. The bottom one of your page, you need some numbers for that. So again, I suggest you pause the video after I give you some numbers on here. Take it back. You don't need any numbers. These are what you're trying to find. All the information is on here. It's all there. And don't overlook the importance of this. This is telling you how to set up your corresponding relationships. Triangle POW is compared to triangle CAT, which is telling you like PO and CA are the same. OW and AT are the same. PW and CT are the same. Without that letter order, there's more than one answer to this, and there's not a condensed set of answers on there. I would rate this as a relatively tricky problem. This is an honors level problem. I think I've given this to my regular math 2 classes before or 1 classes, and this is a really challenging problem for them. To me, I always make it visual. I want to make it something I can draw and see on there. So if I draw those, I know that TC and WP are going to be the same, and I'll eventually go after that. I know that OW and AT are going to be the same. I know that O and A are going to be the same just based on parts on there. And I know that TAC is the letter order backwards, is the same as WOP. So I know those matchups, those parts match up, those corresponding parts match up. Now I'm going to find each triangle's perimeter. Find this triangle's perimeter, that triangle's perimeter, not in terms of X, but actually try to get the values on here based on congruence. This is just a sketch, not drawn to scale, but I'm going to draw this sketch with the exact same orientation. So I know congruent, congruent, and congruent. In other words, congruent, 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 congruent. If it's in the same orientation, it's easy for me to figure out which parts match on there. So I know those are equal. The other thing you also know is that AT and CT were congruent. AT and CT were congruent. That's important, which means if this is 4x, this is also 4x.
4x.
What's up, Mr. Marley?
I'm not Marley.
Oh, okay. So eventually you get x equals a nice fraction on there, 5.5 or 11 halves. Plug it in here, plug it in here, plug it in here. But again, you've got to recognize these are the same, and they're the same as these. So if you multiply that by 4, you get 22. So 22 plus 22, and then plug it in here as well. Hopefully, get a perimeter that's the same for both of these. And it didn't matter if you plugged it in here and then added the 22s on as well. Should have 58.5. So hopefully, I think the homework for this particular section, 712, is pretty easy. There's also a problem of the day, and I have to mention I forgot to emphasize on the last section. If I was in class, I would have you do that challenge me assignment. This problem of the day is straight off Mr. Feiss's excellent work. This one here was the other one. You should have done the last one, the challenge me problems. Really good honors levels problems in there from the last assignment. Hopefully you did those and checked those. Some good thought-provoking problems in there. Hopefully keep you going. Problem of the day is a nice one. Enjoy. We'll see you. We'll see you someday. Hopefully. Adios.